Hello, Mario! In this video, I'm going to be calculating some volumes and contours of a stockpile using contemporary survey software. So let's get on with the job. There are many ways of getting your data into survey programs. Best way is probably to load it in directly from your data recorder. But in this instance here, I don't have any information that's suitable, so I'm using here a CSV file that's comma separated data basically, and I've saved this. This is just using an Excel spreadsheet here, and I save it in .csv format. Now, just to have a look at the format here, what we've got is in column A here we have our just a point number system. Here in B is our northern coordinate, C our eastern coordinate, and D our height or RL, and E here is a coding. BS plus 01, in this instance it's the base of a stockpile, so that's the base string of the stockpile. Just moving down to have a bit of another look at the data, we've got TB01, which is the top of the bank on one side of the stockpile, and TB02, top of the bank on the other side of the stockpile, just to give you a bit of an idea. So I'm going to load this data into our survey software, and it's related to a stockpile. And I'm going to show you one, how I go about loading the data in, and secondly how we might calculate the volumes. There's a couple of ways of calculating the volumes of the stockpile, but I'm just going to demonstrate that in some fairly standard sort of survey software. Alright, let's see if we can get our data loaded and in and start working out some volumes of some stockpiles. So here we go with our survey software program, and we're going to go data input, and we're going to use this format here from our CSV file that we had a look at earlier. So first thing we've got to do is to locate our CSV file, which we will find at under this course on survey computations, volume plans. And of course it's looking for a DAT file, we're looking for a CSV file. So here we go, and quite a number of files here. Just got to locate our CSV files. So one way of doing that is just to go view arrange icons by type, and then that'll put all our CSV files in one place, and here's our CSV file that we're going to load in here. Alright, and default line color is going to be in red, and I like my point colors to be in magenta. Text I like to have as that one there. The default model for the thing, we'll just call it stockpile 01, and we'll put it into view 1. You see the views indicated down here. We don't want the join to think. It's a delimiter as opposed to not fixed width. It's delimiter, it's comma delimited. Now in this program the X is actually the eastings and the Y is the northings, and the Z of course is the height, and these are referring to the columns in their CSV file that I had there. The name of the string that we've put in of course is in the fifth column, and we've got the point number in the first column. That there, if you remember back to the file, it's a pretty standard format that I use, and our delimiter is a comma, and then we just go read, and there we are. There we have our stockpile. We'll notice that this base string here is not closed, so we just go strings edit close, and we close that like so. Now there is a very easy way of just using stockpiles, or a stockpile function, to work out the volume of our stockpile. We'll use the same data. I'll show you some other things a bit later on, but if we go to Design, Volumes and Stockpile, which is what we've got here, and we get this little menu to use here. So the data that we're going to be using is in our view 1 there. We'll work out the surface area as well. The model for the tins, we'll just call that tins S pile. The model for the text, let's call it S pile text. And these models will be created. Now the base string, what we do here is go like this, and then same as, and we select the string that's going to be the base. There it is, accepted. That's that done. The report file, let's call it spile report, like so. The view that we're using, of course, is view 1. Well, there's some text in there, so let's say decimal places. Let's go with 0 and the stockpile number 1, and let's process this and see what happens. And there we are, it's all processed. And what we can see there is that what it has done is it has created a tin, or a triangulated area network, of the base of the stockpile, and it's also created a tin of the actual stockpile itself. It's calculated the volume, 8235 cubic meters, and it's calculated the surface area, 2517. Let's just have a look at our models here, and there we are, like so. If we just look here at the tins, it's created let's have a look at the tins that we've got, project tins. We've got the stockpile of base 1 and stockpile 1. So stockpile base 1 and stockpile 1. Now, and that's got all our areas. The other thing that we could look at here is the report, and we could just edit the report here like so, and that'll give us a report which just gives us the same data that we've got there, total fill, and so on and so on. Now what we'll do is we'll just turn off some of the tins stockpile, just turn that off there, and we'll just turn off the text here as well, and we're just back to where we were with the base. Now there are other ways of doing this, and what I'm going to do up here is just turn on some values. I'd like to know what the Z values might be helpful, so we'll just turn on what our Z values were, and we'll also turn on our string names, and like so. And we've got all that data there, but I just want to show you the method of how things work. And so what I want to do is to create a tin of the base on its own, rather than use the stockpile function there, just to illustrate how we might use the thing. Now to do that, I want to get these points, or these strings here, I want to get them out of the way. So strings edit change, and I'm going to give them a new model. So I'm just going to call them stockpile top, like so, and then we'll start, and what we'll do is we'll just put that in there like that, and accept that, and this one here, accept, and just push this little thing here which just redraws it, and there's our base of the stockpile. Now what I want to do now is to just create a tin of that. So tin here, and I'm just going to create a tin. We'll triangulate the data first, so it's just this data that's here at the moment, which is in 1, and we'll give the new tin name, which will be S-pile base, and we're going to have it green. The model for the tin, I'd leave that open, it'll create its own, which will be tin S-pile base, and preserve strings, and we just go triangulate, and it's done that. But we'll look over here and we'll see here that there's our tin S-pile base, and I'm just going to turn that on now. Now, one of the things you'll see here is that it's created a triangle in through here, which is actually outside our area of the stockpile. Now, what we have to do with that is we have to go to our tins and we have to null that triangle, or remove that triangle from the tin. And this is done manually. There are other ways of doing it by using a polygon, but I'm just going to look at it. I'm just going to do that again. I got over talking. I couldn't think. So it's going to be by strings, and the tin that we're going to be looking at is S-pile base here. We're going to accept there, and we just click on that little line, and what I do is just draw a little line through there, and that's our tin. That's what we call null. And some other tins, of course, there's a lot more triangles to remove, or you can use an exterior polygon. So it's always good to just have an exterior polygon around areas where you're dealing with tins, as that makes that aspect so easy. And of course, every time you do any change to the tin, because that was a manual annulling that manually, you would have to go back and do that again. So let's just turn that tin off. So that's tin stockpile base. Just turn that off and just return to here. And what we'll do now is I have added these S-pile. I've added those in like so. You'll notice that they've got no data associated with them, so that's just a matter here of going into the Z values and turning them on here if you want. If you wanted, I'm just doing this to show you various aspects of what happens and how the software sort of functions. And if we wanted the string names, we could turn them on as well, just for that model that the tops are in. Alright, so now what we're going to do is create a tin of the whole stockpile. So it's just a tin, create, triangulate the data, and it's everything in there now, the same one, not a problem. And we'll call this stockpile all. It's going to be green. That's going to be 1. It'll do its own. Now I can't impress enough the way that you need to manage the creation of these tins, because as you create more and more of them in one job, it can become a bit of a nightmare as to which tin's which. So probably pays to have a bit of a plan before you go in, or certainly write down or make notes. So we're just going to triangulate that tin again, and then of course we need to turn the tin on, stockpile all tin on, and once again we can see we've got that little triangle over there. So I'll just turn this off, and then go here to tins, null by strings, and that's the stockpile all is the one we're going to null on acceptance. Draw a little line there, in there, all done, finish. Okay, so that's our tin. Now we can, although we have that stockpile function, we can then go here to designs and work out our volumes here, and we've got a various different selections. We can use the end area volume or the exact method, which has a more sophisticated calculation, and also I think there's an option somewhere in the software. Oh, there's the end area one there, and this is the exact one here. So, and we're going to go tin to tin here, like so. And so the original tin will be our stockpile base here, like so. And our new tin will be, this is the stockpile all. The range file plan, clean faces beforehand. I don't usually worry about that. Use a polygon. So we can just go volume, and it calculates a volume between the two tins, 8234.812. I'll just put that over to one side, and we'll compare that with the version, with the one just by turning the text on. We can stockpile text. 8235 was there one using the other one, and here we've got 8235 again. So we can see there that that's another way of turning the calculating the volume between two tins, which I wanted to show you a little bit about the creation of tins, and also how they might work. Now there's one further thing that may be of interest to us, and that is creating contours, and that can be done. Each tin can be contoured by just going to tins and contour, and I use this one, contour, smooth and label. There's all sorts of various options, and it enables you to put up a function up here, which means that it stores the mechanism or the stuff that you input, so that you can review what you've done. Now the tin I want to contour is the stockpile all. The model for the contours, I'll just put contours, and the contour interval is 1. The color, I'll go for cyan. I do want them labeled, so I'll just put a 1 in there, I think. And I'm not sure about the weight there, and we will get them smoothed. Major contours, and we'll put them every 5 meters, and we'll make them cyan. The range, well, we'll just leave that how it is. And the labels, there's some options there with the label the contours. There's some options there as to where they are. I usually like them I'll just leave them at the default setting there, and we'll just process that. Text style not set. Oh, silly me. So here we go, text that, and we just process, and the contours have been created, and they're created in a model, hopefully over here, called contours. And here we can see that we've got the contours. This stockpile is very similar to a practical exercise that I have looked at earlier in one of my videos, where we've done this by hand. And we can see here that we've got our contours labelled through here, and we can then turn off the tin if we wish, like so, and just do a quick refresh or withdraw, and there you are. We have our stockpile with contours all done, all from the information. I've put the information in as a CSV file, but it could equally come from a number of different sources.
In this video,
directly from the
I'm
data
going to be
recorder,
calculating some volumes and contours
and what have you.
So using
there you go,
survey
working
software.
out volumes
So let's get on with the
contours
job.
using contemporary survey software.